Hi everyone, Assalamualaikum. In this video, we will continue with example 4 under separable equation for first order ODE. Solve the separable differential equation dy over dx equals to xy cubed over square root of 1 plus x squared, where y0 equals to 1. Right? Y0 equals to 1 means the initial condition. And when the initial condition is given, we need to find the value of c after we integrate, right? When we solve separable equation under first order ODE, first step, we need to separating variables x and y. Left hand side, we want to write fy dy, and right hand side, we want to write fx dx. So from the given question here, we can move term containing variable y to left hand side, and then we can move dx to right hand side. So after we move, we get this. Okay, we move times y cube from right hand side to left hand side. So we get over y cube. And then we move over dx to right hand side. So we get times dx. Alright. Up to this point, we're done separating variables x and y, right? So we can continue with step 2, integrating both sides, right? From here, we just put integration sign for both sides, right? Alright, from here, we can write integration of y to the power of negative 3 dy. We use the properties of indices over y cubed. We can write y to the power of negative 3. Right? And then from x over square root of 1 plus x squared, we can write x times bracket 1 plus x squared to the power of negative half. Negative here because we move up this function using the properties of indices. Half here because square root symbol here, right? Right, then we can name as equation 1 because we want to integrate 1 by 1, right? Right, for left hand side function, okay, we can integrate using power rule, okay? From integration of y to the power of negative 3 dy, using power rule, after we integrate, so we have y to the power of negative 2 over negative 2 plus c. Right? After we integrate, no more integration sign. Right? Or we can write negative, and then we move down y to the power of negative 2, so we get over y squared. Okay? And then we have negative sign in front here. Okay? So we can write equals to negative 1 over 2y squared plus c. Okay? Right. And after that, we need to substitute into equation 1 here. Okay? Right. For right-hand side function, we need to use integration by u substitution. Okay? So when we use integration by u substitution, we need to identify u. In this case, our u equals to 1 plus x squared, the function in bracket. Okay? And every time when we use u substitution, after we identify u, we need to differentiate. Okay? So after we differentiate, we get du over dx equals to, differentiate 1 equals to 0, no need to write. And then differentiate x squared equals to positive 2x. Alright? Then we need to write dx as a subject. So we just cross multiply here. So we get dx equals to du over 2x. Right? Now we want to integrate x times 1 plus x squared bracket to the power of negative half dx. Okay? So we rewrite in terms of variable u and du. Okay? So from here we have x, and then times, we replace 1 plus x squared equals to u, and then to the power of negative half, and then we replace dx equals to du over 2x, right? And then we can simplify x here and x in denominator here, okay? And then at the same time, we can move over 2 out to integration sign, right? Then we have half integration of u to the power of negative half du, okay? From here, we can integrate with respect to u. In this case, we can integrate using power rule because the power here not equals to negative 1. Okay? So after we integrate, no more integration symbol. Okay? We still have constant half in front here. So when we integrate using power rule, we have u and then to the power of negative half plus 1. So we get u to the power of positive half. And then over negative half plus 1 equals to positive half. And then after that, we put plus c, right? Now we have constant half here and half in denominator. So we can simplify, right? So after we simplify, we get u to the power of half. Or we can write square root of u plus c. Okay? And then we replace back u equals to 1 plus x squared. So we get square root of 1 plus x squared plus c, right? And after that, we substitute into equation 1, right? Right now, we substitute left-hand side and right-hand side into equation 1, okay? So the general solution is when we integrate y to the power of negative 3 dy, the answer equals to negative 1 over 2 y squared plus c. Okay? And then equals to, when we integrate x times 1 plus x squared to the power of negative half dx, the answer equals to square root of 1 plus x squared plus c. Alright? We just put plus c on one side only. Alright? Because if we put plus c for both sides, we tend to simplify the constant c. Okay? Right. So from here, this is the general solution. Okay? But we are given the initial condition. So after this, we need to find the value of c using the given initial condition. Right? From the previous slide, we get the general solution is negative 1 over 2 y squared equals to square root of 1 plus x squared plus c. Okay? From here, we are given the initial condition. So, we need to find the value of c after we integrate. Okay? At this point, we done integrate left-hand side and right-hand side in the previous slide. So, we get this answer. Alright? So, now you want to find the value of c. Okay, so we can name as equation 1, equation 2. Okay, because we already have equation 1 in the previous slide. Right? Right. Then we continue with step 3. Okay, applying the given initial condition to find the value of c after we integrate. Okay, so from here, 0 here means the value of x. And 1 here means the value of y. Okay. So we substitute x equals to 0 and y equals to 1 into equation 2 here. Okay, so we get negative 1 over 2 and then 1 squared equals to square root of 1 plus 0 squared plus c. Okay, we replace x equals to 0 here and we replace y equals to 1 here. Right? Right, then we get negative 1 over 2 equals to square root of 1. Okay? Square root of 1 equals to 1. And then plus c. Right? After that, We move 1 to left hand side, so we get negative half minus 1, so we get negative 3 over 2. So this is the value of C. Okay. Then we substitute the value of C into equation 2 here. Okay. Thus, the particular solution is negative 1 over 2y squared equals to square root of 1 plus x squared minus 3 over 2. Okay. The particular solution means when we substitute the value of C into the general solution. Okay. From here, we have C equals to negative 3 over 2. So after we substitute into equation 2 here, so we get this. Okay. This is the final answer. Right? Got it? From the previous slide, we done solve the separable equation and we get the final answer negative 1 over 2y squared equals to square root of 1 plus x squared minus 3 over 2. Right? Is my answer correct or wrong maybe? We can check the final answer. Okay? Right, so from the final answer here, negative 1 over 2y squared equals to square root of 1 plus x squared minus 3 over 2. We can differentiate back and then we can substitute into this separable equation. Okay, if we get left hand side equals to the function on the right hand side, means we get the correct answer. Okay, but before we differentiate, we can rewrite this function. Okay, we have negative half and then we move up y squared using the properties of indices. So we get times y to the power of negative 2 minus, and square root symbol here, we can write bracket to the power of positive half. So we get bracket to the power of positive half and in bracket 1 plus x squared and then minus 3 over 2. Alright? So from here, we can differentiate implicitly with respect to x. Okay, because we want y dy over dx. Right? Right, so from here, we still have constant negative half. And then when we differentiate y to the power of negative 2, we can use power rule. So when we differentiate, we move negative 2 in front here and then y and then negative 2 minus 1. So we get negative 3. And every time when we have variable y and we want to differentiate with respect to x, we will have dy over dx at the back. Okay, this is implicit differentiation. Okay, and then equals to, we can differentiate this using generalized power rule. We move half to front here, so we get positive half here, and then bracket 1 plus x squared, and then to the power of half minus 1, so we get negative half. And after that, we need to differentiate the function in bracket. Okay, so differentiate 1 equals to 0, no need to write, plus differentiate x squared equals to 2x. And the operation here must multiplication operation when we differentiate using generalized power rule. Right? And then minus 3 over 2 here is constant. So when we differentiate any constant, the answer equals to 0. Alright? Right, for this term, we don't need to write, there is no variable y here. So we don't need to write dy over dx. Right? But for left-hand side function here, we have variable y. So at the back, we must put dy over dx. When we differentiate variable y with respect to x. Right? After that, from here, okay, at this point, we are done differentiating. Right? So after that, we can simplify 2 here and 2 in denominator here. Okay? And we also can simplify 2 here and 2 in denominator here. Okay? So after we simplify, we get negative times negative equals to positive. So we get positive y to the power of negative 3 dy over dx equals to 1. We can write x here in front here. Okay, so we get x times 1 plus x squared bracket to the power of negative half. And then minus 0, no need to write. Right? Right now, we want to write dy over dx as a subject. So we can compare with the given question. Right? Right, so from here, we can move down y to the power of negative 3. So we get 1 over y cubed using the properties of indices. Okay, and then dy over dx equals to x. We can move down bracket to the power of negative half using the properties of indices. So we get over bracket 1 plus x squared to the power of positive half. And to the power of positive half means square root. Okay, and after that, we can move y cubed to right hand side. Okay, so we get dy over dx equals to x and then y cubed over square root of 1 plus x squared. Okay, so from here, when we compare from the given question here, it's equivalent, right? So means that the final answer here is correct, right? That's the way how you check the final answer. Is it the final answer is correct or wrong, right? Coming up next, more examples for separable equation. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.